All right, this video is the first part of the Unit 5 test review. Tell whether a triangle with sides of given lengths is acute, right, or obtuse. And so what we're going to do is we're going to compare the C, which is the longest side, and if it is equal, it'll be a right, and if it's less than the sum of the squares of the other two, it'll be acute. If it's greater than the sum of the squares of the other two, it'll be an obtuse. So let's try number 1. We know that 18 is the biggest number, so that's our C. All right, so we're going to compare 18 squared compared to 8 squared plus 15 squared. And so let's see, I don't know what 18 squared is, so let's go to Desmos. 18 squared is 324. So this is 324 compared to, well, 64 plus 225. 225 and 64 is 289. So 324 is greater than the sum of the squares of the other two, and so this is an obtuse. All right, let's try number 2. Square root of 2 is the biggest side. That's our C. So we have the square root of 2 squared, and we're going to compare that to, well, 1 squared plus 1 squared. Square root of 2 squared is just 2. Compared to 2, that's equal. So this is a right. Okay, let's try one more. This is our biggest, so that's our C. So 15 squared compared to 8 squared plus 13 squared. 225 compared to 64 plus 169, and 169 plus 64. 233. So 225 is less than, so it's acute. All right, let's skip to number 5. We're just going to simplify each radical. Let's just practice a couple of these. Let's start with, I guess, just number 5. I always do a factor tree with my smallest prime number, which is 2, and I use it until I can't use it anymore. If you have a pair, that goes out. If you are single, you stay in. So this is just 2 roots 5. Let's jump over to 180. So factor tree on 180, 2 and 90, 2 and 45, 3 and 15, and 3 and 5. In this case, we have 2 that come out. So 2 times 3 is 6, and a single 5 stays in. And that's how you simplify a radical. Let's practice a few finding the value of x in each of the following, and leave your answers in simplified radical form. All right, so this is, well, we have 2 congruent sides. That means these base angles are congruent. Now, it might not look like it, but because each side is marked with a 5, we know this is an isosceles right triangle. That means base angles are congruent. This is a special 45, 45, 90. And the ratios of these sides is xx, x root 2. When we're trying to find the hypotenuse, we would just multiply by root 2. So that hypotenuse in this case is just 5 roots 2. In problem number 12, what I want you to notice is that we have 4s on each side of these triangles. So this is an equilateral triangle, equal angular triangle. So this angle at the top is 60, and each of these angles is 60. But notice the angle at the top is being cut in half. If I just take a look at one of these triangles, this guy right here, that means I've got a 30 because I cut the 60 in half, 60 and a 90. So 30, 60, 90, and the ratios of those sides are x, x root 3, and 2x. Now, what do we know? Well, across from the 30, if we cut 4 in half, would be 2. That's the value of x. So across from the 60 is what we're looking for right here. That would be 2 roots 3. And then just to verify, across from the 90 would be 2 times 2, and that's 4. And so that verifies. In problem number 13, this is a multiple of one of our Pythagorean triples. 3, 4, 5. See, we have 6, 8, so I know my hypotenuse is going to be 10. Now, if you wanted to verify with Pythagorean theorem, 36 and 64 add to 100, and the square root of 100 is 10. Okay, in number 14, we're just going to work through Pythagorean theorem because we have a right triangle. And so let's see, this is my C, my hypotenuse. So I've got x squared plus 20 squared is equal to 22 squared. X squared plus 400 is equal to, wow, that looks funny. It should be, let me make that 2 a little smaller. 22 squared. And let me see, what is 22 squared? 484. So this is 484. And so if I subtract 400 on both sides, I have x squared is equal to 84. And then I want to do a factor tree. So this is 2 and 42. Let's see, 2 goes in 21, and 3 and 7. I have a pair of 2's that come out, and a 3 and 7 go back in. So this is 2 roots 21, and that's our simplified radical. Let's skip over to number 16. And on number 16, we have a square, and so that we know each of these sides are 3.5, and squares also have right angles, so these are going to be bisected. This is a 45, 45, 90. If I'm trying to find the hypotenuse, if I'm looking at just one of these triangles here, the hypotenuse is just going to multiply the leg by root 2. So 3.5 roots 2, and that one's done. Okay, let's see. Maybe we'll practice one more. How about number 18? So 13 is the distance from here to here. And let's figure out, if I just take one of these triangles, this guy right here, and I know he's a right triangle, and I want to find this little guy right here. I don't want to call him X. I'll call him A. That would be just this distance here. Then I could double it, add it to 13, and find the length of the whole side. So a squared plus, well, across the box is your hypotenuse. So it's going to be 15 squared is equal to 17 squared. 225 is equal to 289. If I subtract 225, this one I think is a Pythagorean triple. So let's see, that would be 9 minus 5 is 4, 8 minus 2 is 6. Yep, a is equal to 64, so a squared is equal to 64, so a is equal to 8. Okay, let's take a look at some more problems now. A rectangular pool for swimming has a length of 30 and a width of 16. So let's start with a picture. 30 and 16. A life preserver must be located nearby and have a rope at least as long as the diagonal of the pool. How long must the rope be? All right, here's our right triangle. If I want to find across the box, that's my hypotenuse, or my C value. 16 squared plus 30 squared is equal to C squared. And I know 30 squared is 900. Let me calculate 16 squared. Oops. 256. So let me see, 56, 1156 is C squared, and we take the square root. So C is equal to square root 34. That's the length of the diagonal. In number 20, Tiffany drew a right triangle QRS on a sheet of paper. What is the perimeter? All right, so I've got the hypotenuse. This is my C. And let's call this guy A and this guy B. So A squared plus 72 squared is equal to 97 squared. And let's do a little bit of math here. $72 squared is 5184, and 97 squared is 9409. 5184. Okay, let's subtract 5184 on both sides. And a squared is equal to 4225, and if I take the square root of that, $65. Okay, so that missing side of my triangle, the A, is 65. The question asked me for the perimeter. So I'm going to go ahead and just clean this up a little bit real quick because I want to get rid of that. Say this is 65. The perimeter is adding up all the sides, 97, 72, and 65. When I add those three up, I get 234. That's the perimeter of this triangle. All right, two more to go. Joel plans to drive to the store, then stop by Lauren's on his way to Rachel's. So Joel, Lauren, then Rachel. All right, so I guess this would be 20 if from here to here is 17 and the whole length is 37. And we want to see, it says if he takes Firefly Lane at the end of the day to get back home, so we want to figure out what this is. Here's the right angle, so that's our hypotenuse, that's our C value. 20 squared plus 15 squared is equal to C squared. And let's see, 400 plus 225, 625. All right, so C is equal to 25. That's Firefly Lane. And the question says, what is his total mileage? So he went 37 miles this way, 15, and then 25, plus another 17 to get back home. So 17 plus 30, whoops. I don't want to count the 17 twice. If we start here, this whole length is 37. So 37 plus 15 from Lauren to Rachel's plus Firefly Lane is 25 plus 17 to get back home. All of these added up is 77 miles. And the last problem, it says the 13-foot ladder is placed 5 feet away from a wall. Here's my wall. Here's my ladder. This is 5 feet away from the wall. The distance from the ground straight to the top of the wall is 13 feet. Will the ladder reach the top of the wall? Okay, let me redraw this. I think the 13 is supposed to go right here. Because will the ladder reach the top of the wall? We've got to figure out what is the top of the wall. All right, so here's my angle, here's my right angle. This would be opposite, and I know my adjacent, but I don't need to do trig, I just need to do Pythagorean theorem. So let's rethink this. Let's call this my A, and this is my B, and we know that the B is 5 feet away. Across the box, that's my C value. So A squared plus 5 squared is equal to 13 squared, and A squared plus 25 is 169. A squared, if I subtract 25 on both sides, is 144. So A is 12. If I have a 13-foot ladder, it will reach the top of a 12-foot wall. So yes, it'll go over. And that is part 1 of